I am Dr. Anantaya MB, Professor and Head of Civil Engineering Department, Sai Vidya Institute of Technology, Bangalore. As we studied bending moment and shear force in the class, as a part of this we will solve some problems on bending moment and shear force diagrams. Before that, we have to see some sign conventions. The first sign convention is sigma v equal to 0. That means summation of all the vertical forces should be equal to 0, treating upward forces positive, downward forces negative. Similarly, all the summation of all the horizontal forces should be equal to 0, treating rightward forces negative, positive, leftward forces negative. Similarly, sigma m equal to 0 means summation of moment should be equal to 0, treating clockwise moments positive, anti-clockwise moment negative. Similarly, for the shear force, sign convention is if the section line is taken, to the left of the section line, upward forces are positive, downward forces are negative. To the right of the section line, upward forces are negative, downward forces are positive. Similarly, for the bending moment, to the left of the section, clockwise moment is positive, anti-clockwise moment is negative. To the right of the section, clockwise moment is negative, anti-clockwise moment is positive. Let us see one problem on drawing bending moment and shear force. A simply supported beam is subjected to a point load of 15 kN together with the UDL of 15 kN per meter applied as shown in the figure. Draw the shear force diagram and the bending moment diagram. Find also the zero shear point and its corresponding bending moment. This is the problem given. The diagram is also given. This point is A, B, C, D. At C1 15 kN load is there. From D to B, UDL is there of 15 kN meter. Our first aim is to calculate the determination of reactions. It will develop reaction at the supports. One is VA, another reaction is VB. Two reactions will be developed. So we have to calculate. First step is determination of reactions VA and VB. Determination of the reactions VA and VB. First, for calculation determination of the reactions, what are the first conditions is summation of all the moments about point A should be equal to 0. That means taking moment of all the forces about point A is equal to 0. That is sigma MA equal to 0. Now you see, I am taking moment of all the forces about point A. Here 15 kN about point A will create clockwise moment. This clockwise moment will be force into distance. Force is 15 kN, distance is 1 meter. So it is clockwise, therefore it is plus. I am writing it as 15 into 1. Similarly, the UDL is there. Next load is this UDL. Moment of the UDL is 15 into 1.5 into its CG distance and its CG distance from A. Its CG distance from A, it is 1 plus 1.5 by 2 means 0.75. It is 2.75 meter. 2.75 meter. Therefore, total load is 15 into 1.5. It will also create clockwise about this point. Therefore, plus 15 into 1.5 into 2.75. Now, I taken moment of 15 kN load. I taken this moment of this UDL. Now, this VB will create anti-clockwise moment about A. Therefore, it is minus VB into its perpendicular distance from A is how much? It is 1 to 3.5 meter. 3.5 meter. Therefore, it is VB into 3.5 equal to 0. From this, we can calculate what is the value of VB. It is 21.96 kilonewton. We calculated VB 21.96 kilonewton. Now, we calculate the VA now. How? Next equilibrium condition is summation of all the vertical forces should be equal to 0, treating upward forces positive, downward forces negative. Now, what is upward force? VA is upward force, therefore I am taking it as VA. 15 kilonewton is downward force, therefore minus 15. This UDL is acting downward. Total UDL is 15 into 1.5 minus 15 into 5 plus VB is upward, VB equal to 0. From this VB you can substitute here, then you are getting this value VA equals 21.96 kilonewton. 21.96 kilonewton. Now we calculated the reactions VA and VB. VA and VB. VB is 21.96. Therefore, this VA comes 15.54 kilonewton. This is 15.54 kilonewton. 15.54 kilonewton, not 21. It is 15.54 kilonewton. We calculated VA and VB. Next, our aim is to calculate the shear force calculations or calculation of shear forces. Calculation of shear forces. See, shear force means we have to calculate if point load is there to the left or right. One more, shall I write here only? Okay, I write one more figure. It is VA. We calculated VA equal to 15.54 kilonewton. VB equal to 21.96 kilonewton. Here 15 kilonewton load is there. Here UDL is there. This distance is 1 meter. Again this distance also 1 meter. This distance is 1.5 meter. The intensity is 15 kilonewton per meter. Now these are our points. This is A, this is B, this is C, this is D. Now I am taking the shear force A left. If point load is there, I am taking left as well as right. This also point load left, right. This is not point load at D only. This is point load left, right. If point load is there, I am calculating the shear force left and right. Now I am calculating the shear force left of A. Left of A means my section line is here now. My section line is left of A. Left of A. A left. Shear force A left. Left means I am considering what all the forces are there to the left of the section. To the left of the section there is no forces. Therefore, it should be equal to 0. Now, shear force A right I am calculating now. A right means right of this. Right of this means now I am section line is here. Right, just right of A. Just right of A. I am taking all the forces left of that section line. The left of this section line is only one upward force is there, VA. Therefore, to the left of the section, sign convention is upward forces are positive, downward forces are negative. Now this is the section line left, upward is VA, therefore it is positive 15.54 kilonewton. Similarly, shear force C left. C left. Now our section line is at C left here. This is the section line. I have to consider all the forces. I have to consider all the forces left of this section line, not right, left. The left of section line, one VA is there, 15.54. Only that is there. Therefore, the C left is 15.54 kilonewton. Now I have to take section at C right. Right means here. Just right of C. I have to take all the forces left of that section. Here, how many forces are there? Shear force C, shear force C right of C. Here how many forces are? VA is there, 15.54 kilonewton. Then again 15 kilonewton minus 15 is there. Any other force? No, only 0.54 kilonewton. 0.54 kilonewton. Next we have to go to shear force at D. Because not left and right, why I am calculating? No point load. It is the beginning of the UDL at D. Now my section line is at D. I have to consider all the forces left of this section line. Therefore, one is 15.54 upward minus 15. Same forces are there, nothing is there. Therefore, minus 0.54 kilo Newton. Now, shear force B left. Shear force B left means here. Now, left of B. Just left of B. I have to consider all the forces left to this upward positive, downward negative. Therefore, shear force at B left equal to 15.54 minus 15 minus this UDL 15 into 1.5 equal to 15 into 1.5, that is at B left it is equal to minus 21.96 minus 21.96 kilonewton. Minus 21.96 kilonewton. Shear force at B right. Here now my section line is B right. I have to consider all the forces, that is equal to upward 15.5 minus 15 minus 15 into 1.5 plus 21.96 equal to 0. That means at the extreme ends the shear force B right is 0. B right is 0. Now we calculated the shear force. Next we have to draw the shear force diagram. For drawing the shear force diagram, we have to draw a reference line. First we have to draw a reference line. This point is A, this point is B, C, D. On the center line 0, above this positive values we have to mark, below this negative values we have to mark. Now I am marking the values. At A left 0, A right is 15.4. That means it is same, left and right points are same. It varies from 0 to 15.54 positive kilonewton. Again it is A right, A left is 0, right is this. It is same point. It varies from 0 to 15.54. C left is 15.54. Again it is same. It is horizontal. It is same. This also 15.54. C right, C left. C right is, it comes down by 0.54. This is 0.54 kilonewton. C right. D is again 0.54. It is same. If you join, it is 0.54 kilonewton. Again at B left is minus 21.96. You see here, from here to here UDL, therefore the shear force variation is inclined straight line. B right is 0, therefore it varies from 21.296 to 0. This is the shear force diagram. If above this reference line it is positive shear force, below it is called negative shear force. Now if you want, you can hatch this. Hatch this negative and positive shear force. So you see here the shear force is 0. Shear force equal to 0. The bending moment is maximum. Where the shear force is 0, the bending moment is maximum. We have to calculate that 0 shear point and also we have to calculate the maximum bending moment. How to calculate? Some similar triangle property. From this triangle, two triangles, we can calculate the position of this. From D to B, the distance is 1.5 meter. From D to B, the distance is 1.5 meter. I am taking the separate figure separately here. See, this value is 0.54 kilonewton. This value is 21.96 kilonewton. The total distance is 1.5 meter. This distance is x. Then remaining distance will be 1.5 minus x. 1.5 minus x. From similar triangle property, it is possible to calculate this x distance. I am writing here 0.54 by x. 0.54 by x equal to 21.96 divided by 1.5 minus x. 21.96 divided by 1.5 minus x. From this we got x equal to 0.036 meter. Therefore zero shear point is at a distance of 0.036 meter from point D. This is the location of the your maximum zero shear point. Therefore at this point the bending moment is maximum. Now we can draw bending moment diagram. Now third step is bending moment calculations. Bending moment calculations. Again I am writing the diagram. It is VA. We calculated it is 15.54 kilonewton. It is VB 21.96 kilonewton. Now here 15 kilonewton load is there. Here UDL is there. The intensity is 15 kilonewton per meter. This distance is 1 meter. This distance also 1 meter. This is 1.5 meter. Now we have to calculate what is the bending moment at different points, and we have to draw the bending moment diagram. So this point is A, this point is B, this point is C, this point is D. See, I am writing now bending moment at A equal to 0. At the extreme points the bending moment is 0 because I am considering the section here. To the left of the section no beam itself, therefore bending moment at A equal to 0. Next, bending moment at C equal to, now my section line is here at C. I have to consider left portion. The bending moment, the VA will create clockwise moment to the left. To the left clockwise will be positive. Therefore 15.54 into the distance is 1 meter. It is kilonewton meter. 15.54 kilonewton meter. Next, the bending moment at D. Bending moment at D. Now my section line is here. I have to consider all the left portion to this left of this section line, left of this section line. Now VA will create clockwise moment about D, then VA into this distance 2. Therefore 15.54 into 2, it is 15.54 into 2 minus this will create anti-clockwise moment about D, this 4. This is 15 into 1, 15 minus 15 into 1, that should be equal to 16.08 kilonewton meter. Now bending moment at B is 0, extreme ends B equal to 0. Now I have to write the bending moment diagram. Again this reference line, this point ECA, B, C, D. Bending moment at A is 0, C is, bending moment C is 15.54 kilonewton meter. The variation is linear because there is no UDL, therefore it is linear. Now bending moment at D is 16.08, here just above. So again it is a inclined straight line. Next, bending moment at B is 0, but here UDL is there, therefore bending moment variation is parabola. So because of UDL, parabolic variation. This bending moment is positive. Above the reference line. It is called BMD. Now we have to calculate what is the maximum bending moment. Maximum bending moment at zero shear. The maximum bending moment at zero shear point. That is in the beam. Where is the zero shear point? It is the beam. VA we calculated 15.54 kilonewton. VB we calculated 21.96 kilonewton. Now here 115 kilonewton load is there. This distance is 1 meter. Here UDL is there. This distance also 1 meter, 1.5 meter. The zero shear point is at a distance here. The zero shear is here. This is at a distance of from D. This point is A, B, C, D. 0.036 meter. We have to calculate the bending moment at this section line considering all the forces to the left. Therefore from here to here the distance is 2.036 meter. From here to here 1.036 meter. Now I am calculating the maximum bending moment. Therefore I am calling this point as F. Maximum bending moment BM at F equals VA into, this will create clockwise about this point, therefore 15.54 into 2.036. This will create anti-clockwise about this, minus 15 into 1.036. Next this UDL is the intensity is 15 kilonewton per meter. 15 into, it is also create anti-clockwise, therefore minus 15 into 0.036 into half of this, into 0.036 by 2. It comes nearly 16.085 kilonewton meter. Such we calculated the maximum bending moment and the bending moment and shear force diagrams.